All right, get excited for lesson 4.4. We've looked at relations, graphing, functions, writing functions. Now we're going to work on graphing our functions. Our first example, we're going to graph the solutions to this equation with the given domain. If you notice, our domain just has 4 values, so we're going to end up with 4 ordered pairs that we're going to plot on our graph. First thing we want to do, however, is take our equation and we're going to solve this for y. So we're going to add that x to both sides. So we have 2y equals, and we are going to put the x first and then the plus 6 after. X and 6 are not like terms, so they'll just go side by side. And then we're going to divide by 2, and we're going to divide everything on the other side by 2. So our final equation is y equals this x over 2. Think of it like a 1x over 2, or we can just say 1/2 x, and then positive 6 divided by 2 is positive 3. All right, so to organize our work, we are going to create a nice little table. I'm actually just going to go ahead and draw it around the equation we already have. I'm going to put this in the middle. Okay, so our domain, these are the x values that we're going to plug in. That's our input. So in the x column, I'm just going to list those. We have -4, -2, 0, and 2. And then maybe I'll just draw these lines now that I have the numbers in. Hopefully you guys can get yours a little bit neater than mine. I'm not working with the best stylus right now. Okay, so we're given the input values, our x's. We're going to put them into our equation, into our function for the x, and that's going to tell us the y value, which we'll put over here, and then we will have our ordered pairs to graph. So if your x value is a -4, that means that we're going to take, oops, I don't want the highlighter, there we go, 1/2 times -4 plus 3. Now 1/2 times -4 is the same thing as saying what's half of -4, so that's a -2 plus 3. -2 plus 3 is a positive 1. So our input was -4 and our output was 1. That's an ordered pair. We can go ahead and plot that on the graph. The x is a -4, so we're going to go over 1, 2, 3, 4, and the y is a positive 1, so we're going to plot a point right there. -4, 1. Oops. Okay. Next we're going to plug in a -2, so we're going to do 1/2 times -2 plus 3. So half of -2 is -1 plus 3, and -1 plus 3 is a positive 2. So that ordered pair, our x is -2, so you go 2 to the left on the x-axis, and our y is a positive 2, so that's going to go right there at -2, 2. All right. Now our input, or our x value, is a 0, so we're going to say 1/2, plug in a 0 for your x, plus 3. Well, 0 times anything is just 0, and 0 plus 3 is 3. So our input was 0, our output was a 3, that's your x and your y. So when you're at the origin, if your x is a 0, you're not moving to the left or right at all. All you're doing is you're going to go up 3 and plot your point right there. All right, last one. We're going to plug in a 2 for your x, that's our input. Half of 2 is 1, and 1 plus 3 is 4. So on the x-axis, we're going to go 2 to the right for your positive 2x, and then up 4, and plot that point right there. So we have graphed the solutions given a specific domain. So if you have just however many values in your domain, that's how many points you're going to have on your graph. All right, so here's another function for us to graph. If you notice, it did not give us specific domain values. So what we're going to do is we're going to come up with domain values that kind of make sense with the graph that we're given. First thing though is you do want to have your equation solve for y. I do notice it's solved for y, just y is on the other side. So I'm going to just flip that whole thing around. And we're going to say y equals 2x plus 1. We're going to go ahead and turn this into a table, just like we did on our last example. And we're going to pick some reasonable domain values given our graph. So what I mean by reasonable domain values is we could plug in anything and for the x, you know, any input value. If we plugged in a -10, what I notice on our graph is this only goes up to -7. We don't even have a -10, so that point would be off of our graph somewhere. So let's pick domain values that are along the x-axis that we can see right here. Really common ones are to go -2, 1, 0, 1, 2, kind of right at the heart of the graph so that we can see what it's doing. So I'm just going to say -2, -1, 0, 1, and 2, and we will just do some quick little math and plug those values in. Okay, so again, just like the last example, we have our input of -2. So I'm going to do 2 times -2 and then add 1. That's -4 plus 1, and -4 plus 1 is a -3. So our ordered pair is -2, -3, and we can go ahead, and plot that over there. All right, our next input value, or x value, is a -1, so we're going to do 2 times -1 plus 1. 2 times -1 is -2, and -2 plus 1 is a -1. So -1, -1, we'll plot that point. So the more you do these, you can tell that they do get a little bit faster when we don't talk through we're talking through all the details, but you know, we can kind of speed it along a little bit. Now we're going to plug in a 0 for our x, which again is our input. 2 times 0 is 0, 0 plus 1 is 1. We'll go ahead and plot that. Plug in a 1 for our input, our x value. 2 times 1 is 2, plus 1 is 3. So that ordered pair, 1, 3. And then we just have one more, plugging in a 2, so 2 times 2 plus 1, 4 plus 1 is 5. So our x's are 2, our y is a 5. Okay, so if you notice, we do have, with kind of the domain we came up with, a reasonable domain for our graph, just -2 to +2, you know, the heart of our graph right here, we can see that a pattern is formed. So all we're going to do now is we're going to go ahead and connect all those points, because we could plug in a lot more x values to get the rest of the line, but we just plugged in a handful so that we could get an idea of what the graph was going to look like. All right, so we're going to find values from a graph. So if you're given the graph, you can find function values for specific inputs or x values, depending on what they're asking. So here we have a graph, f of x equals 3x minus 2. So here's our function right here. We're going to use the graph to find the value of f of x when x equals -1. So what they're asking us to find is f of -1. So to use the graph for that, we want to focus on the x-axis, which is going to be this axis right here. And we are going to go to where x is equal to a -1, right here. We want to figure out where does our function or our graph or our line cross this value when x is equal to 1. So all I'm going to do is I'm going to draw down until I can see it's hitting right there. So the question is, what is the value of the function? And that is going to be the y value. So we can just count down on our graph. We're at 0, -1, -2, -3, -4, -5. So the value of our function when x is a -1 f of negative 1 is equal to negative 5. And we were able just to use the graph of the function to get that answer. All right, here's our last example for the intro video. This is a problem-solving application. So the function y equals 2.5x describes how many millimeters sea level rises y in x years. Graph the function, so that's the first thing we're going to think about doing. And then using that graph, we're going to try to estimate how many millimeters sea level will rise in 3.5 years. So first thing, graph the function. Now when we graph the function, we're going to make our table of values like we did on the last couple examples. If you notice, they did not give us any domain values, any x's. So we are going to go ahead and come up with some reasonable domain values ourselves. And because this is a situation, this is, there's context to all of these numbers, the number of millimeters sea level rises in however many years. We do want to think about what are some reasonable x values or some reasonable domain values. So first think negative numbers. Does it make sense for you to have a negative number of years? No, it doesn't. So we're not going to use negative numbers. Can you have 0 number of years? You can. That would be at the very start. And then 1 year, 2 year, 3 year, 4 years. So numbers like that we're going to use. So we'll go ahead and start with 0. Let's just go 1, 2, and 3. That's going to give us 4 ordered pairs. That should be, well, no, actually it says we have to go up to 4. And I will explain why when we get to it. We're going to go all the way to 4. All right, so we'll go ahead and make our table. We have our input and our output y values over here. All right, so our input of 0, we're going to do 2.5 times 0, and that is just 0. And we'll talk about graphing, putting this on the graph in a second. Plug in a 1, so 2.5 times 1 is just going to give us 2.5. 2.5 times 2 is going to give us 5. 2.5 times 3 is going to give us 7.5. And then 2.5 times 4 will give us 10. Okay, so when we go over here to our graph, I should have maybe moved this to the left a little bit now that I can see what we're doing. We're going to go ahead and put the x-axis down here on the bottom and the y-axis over here on the left. The reason for that is you can see that we don't have any negative x values, so we didn't have to go over here on the left at all. We didn't have any negative y values for our answers, so we don't have any of our graph down there. We're dealing kind of in all positives because of the situation that we're in. Okay, so our x is 0, 1, 2, 3, 4, so 0 will just be right there. And then I might just count by 2's because there's, this graph is so big, I don't want it all squished there at the origin. Oh, there we go. So I'll make that a 1. That's my 2, 3, and 4. And then for the y's, we do have to go up to 10, so I might just count and see what does this even go up to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. It does go up to 20, so we could fit counting these kind of going by 2's as well. So 1, 2, 3, 4. All right, I just paused it a minute and kept going. The other thing we're going to want to do with our graph is label our axes. So our x-axis, they told us was time in years, so maybe we'll just be specific and say it's time in years. And they said that our y-axis was millimeters, or sea level in millimeters. Okay, that's really sloppy, but you guys see what we're doing. Okay, now we're going to plot our ordered pairs. So we have when our input was a 0, our y was a 0. So that's just right here at the origin. When our x was a 1, our y was a 2.5, so that's going to be right there. When our x was a 2, our y was a 5. When x was 3, y was 7.5. And then when x was 4, y was 10. Up here. Okay, so we are going to go ahead and draw in our line. Maybe I'll use yellow. We can tell everything is forming a pattern based off of the domain that we put in. We got that line right there. So that's the first thing they wanted us to do, was to graph the function. So we did that. Now we're going to use the graph to estimate how many millimeters sea level will rise in 3.5 years. So we want to use our graph for this. We want to go to 3.5 years on the x-axis. So that's 3.5 years right here. We're going to go up to our graph and see where we hit our graph. Right about there. And then we're going to go over and see, well, how many milliliters is that. So looks like 8, it's between 8 and 8.5. So we're going to say 8.25, and we're estimating, and that's okay. Is it millimeter? It's milliliters, right? If it's sea level, or millimeters. I don't know, what is it? Millimeters, just kidding. There we go. Okay, so about 8.25 millimeters.